When did the study of mind started? It didn't begin in a lab. It began around fires, under stars, in silence. Long before the word mind existed, humans noticed something strange happening behind their eyes. Something that could remember, imagine, desire, and reflect. Something that wasn't the body, but seemed to live inside it. In ancient India, around 1500 BCE, early Vedic texts spoke of manas, a subtle internal faculty for thought and emotion. The Upanishads later introduced Atman, the inner self, not as an isolated identity, but as something connected to the entire cosmos. The mind was seen as both individual and universal. In ancient Egypt, the soul was divided into ka and ba. One stayed with the body, the other wandered in dreams. Egyptians preserved the brain during mummification, but some believed thought came from the heart. Others thought it came from breath or spirit. Then came Greece. Around 500 BCE, philosophers like Heraclitus and Parmenides began asking, what is thought? What is being? Plato offered one of the first structural theories of mind, a tripartite soul with reason, emotion, and desire. Aristotle, more empirically minded, described the mind in terms of functions, perception, memory, imagination, and reasoning. In China, Taoist thinkers viewed mind not as a substance, but as a flow, a process aligned with nature. In early Buddhist thought, the mind was not fixed, but constantly changing. What we call a self was considered an illusion, a moving collection of processes mistaken for something stable. The study of the mind didn't stay within philosophy. During the Islamic Golden Age, thinkers like Avicenna and Al-Farabi wrote about how thought might rise from the body and how intellect could transcend it. In medieval Europe, the mind was studied through theology, through ideas of free will, moral reasoning, and divine intention. The real shift came in the 1600s with René Descartes. He asked, "What can I know for certain?" His answer, "I think, therefore I am." With that, the mind became not just a subject of reflection, but the foundation of all certainty, a starting point for a new kind of inquiry. From there, the study of the mind branched into science, first with early psychology, then with cognitive science, neuroscience, and artificial intelligence. Today, it spans everything from brain imaging to behavioral economics. But the search didn't begin in labs or journals. It began with a pause, a breath, a question. What is this that thinks? What is this that dreams? What is this that wonders what it is? And it's a question we still haven't finished asking. What is the biology of mind? When we ask what the mind is, we often leap to thoughts, feelings, or awareness. But underneath all of it lies something more basic. Biology, a structure, a system, a living architecture designed not to think abstractly, but to keep an organism alive. The mind begins with the body. Even before the brain, life evolved to respond. Single-celled organisms react to light, heat, pressure. They don't have minds, but they sense. And sensing is the first step toward awareness. Fast forward hundreds of millions of years, and nervous systems emerge. Networks of cells designed to coordinate movement, track changes, adapt to threat. These systems begin simple, nerve nets in jellyfish, ganglia in worms. But over time they layer, branch, fold. Eventually, biology gives us the brain. Not a singular control center, but a decentralized modular network. Different regions specialize: vision, movement, memory, emotion, communicating through electric signals and chemical messengers. And yet, the brain doesn't float in isolation. It's embedded. Every signal is tied to a heartbeat. Every thought echoes hormonal rhythms. What we call mind is shaped by hunger, fatigue, temperature, posture. The brain interprets the world through the body, and the body through the brain. This is called embodied cognition. The mind isn't just in the body, it is the body processing itself. Even more striking is the role of feedback. The biology of the mind is not linear, it loops. Signals travel from the body to the brain and back again. You don't just feel fear and then run. Sometimes you run, and your brain decides you're afraid. Biology is not cause, then effect. It's cause, effect, response, update, repeat. And this system didn't arise overnight. Evolution built it piece by piece. Older brain structures, like the brainstem and limbic system, manage survival, breathing, reflexes, emotion. Newer parts, like the neocortex, handle abstract thinking, language, simulation. But even the newest parts are stacked on ancient foundations. That's why the mind sometimes contradicts itself. One part wants logic, another wants safety, another wants approval. Biology layered these motives across time, and now they all live together in the same skull. So when we speak about the biology of the mind, we're not talking about a single organ. We're talking about a living system, cells, tissues, networks, hormones, feedback loops, all wired together to turn sensing into meaning, meaning into memory, and memory into action. This system doesn't think because it was designed to. It thinks because, over time, thinking helped it survive. The mind is not a ghost in the machine. It's the machine learning to imagine itself. And underneath every moment of awareness, the biology is still running, quietly, continuously, doing its ancient job. What is the chemistry of mind? Every thought you've ever had was soaked in chemistry. But unlike the electrical pulses that travel through neurons, chemistry works slower, deeper. It lingers. It shapes how long a feeling lasts, how strong a desire becomes, how easily a memory settles in. At the core of this chemistry are neurotransmitters, tiny molecules that carry messages from one neuron to the next. One neuron fires. At the end of its axon, it releases chemicals into the synapse. These chemicals drift across the gap and bind to receptors on the next neuron, triggering it or silencing it. But not all neurotransmitters do the same thing. Dopamine fuels motivation and reward. It spikes when we anticipate a goal, not just when we reach it. That's why it governs addiction as much as ambition. Serotonin helps regulate mood, sleep, appetite, and social behavior. A drop in serotonin can shift your worldview, making everything feel heavier, slower, grayer. Norepinephrine kicks in during stress, sharpening attention and quickening the pulse. It helps you focus in danger, but can make stillness feel impossible. GABA calms the system, preventing overexcitation. Without it, thoughts race and rest disappears. Endorphins mask pain and induce pleasure. They're the reason a deep laugh, a long run, or a moment of connection can feel like relief. And beyond neurotransmitters, the brain is flooded with hormones. Long-range chemical messengers like cortisol, oxytocin, and adrenaline. These don't travel neuron to neuron. They move through the bloodstream, adjusting the emotional weather of your entire system. Oxytocin deepens trust and bonding. Cortisol prepares you for stress, but over time, too much wears the body down. Testosterone and estrogen don't just shape the body. They shape emotion, decision-making, even risk tolerance. This chemical web is constantly adjusting. Your brain is not chemically neutral. It's always leaning one way or another, primed for caution or confidence, openness or withdrawal. And while we like to think that thoughts come first, often It's chemistry that sets the stage. You don't feel hopeful and then get a dopamine hit. You get a dopamine hit, and then the world seems full of possibility. Even the placebo effect, long dismissed as imagination, is powered by real chemical shifts, belief triggering biology. So what is the chemistry of the mind? It's not just mood swings or mental states. It's the hidden script behind every behavior, thought, and shift in attention. A molecular conversation running beneath the dialogue of consciousness. The mind is not made of chemicals, but it listens to them, and sometimes the smallest molecule can steer the biggest story. What is the physics of mind? The brain is made of matter, but the mind, the movement, the thought, the feeling, feels like something else. Still, if it exists in the universe, it must follow its rules, and those rules begin with physics. At its simplest, physics studies how things change, how systems store energy, move, evolve, and decay. So what happens when we apply that lens, not to stars or particles, but to thought? One starting point is energy. Your brain, though small, uses about 20% of your body's energy. Every thought is an exchange, a cascade of ions, a shift in electrical charge, a chemical event triggered and reset. But the energy itself isn't thinking. It's the organization of it that matters, and that brings us to information. In 1990, physicist John Wheeler offered a phrase that still echoes through both science and philosophy. It from bit. He proposed that everything in the universe, even particles, even space, might emerge from information, not substance, but distinction, yes versus no, bit by bit. So what if the mind isn't just running on information, but is made of it? Neuroscience already leans this way. Thoughts aren't just electrical pulses, they're structured pulses, patterns, signals that can be encoded, compressed, translated. In this view, the brain becomes an information processing system, and the mind becomes a story that information tells itself. And physics adds another idea, entropy, the measure of disorder. Every system tends to drift toward chaos unless energy is used to hold it together. The mind pushes against that tide. It organizes, predicts, simulates. It makes meaning out of noise. When you learn something, your brain reduces uncertainty. It increases order. It reshapes entropy into structure. And every time it does, there's a physical cost. Tiny, measurable amounts of energy converted into insight. Some physicists even wonder if consciousness is tied to integration, the binding of information across systems. The more information is linked and irreducible, the richer the experience. This echoes what some neuroscientists call the phi value, a number representing how much information is being unified in the brain. And then there's the quantum question. Some speculate that consciousness may not be purely classical, that at the smallest scales, in the flicker of ions or the coherence of molecules, there may be quantum effects shaping awareness. It's still unproven. But the question remains, if physics governs everything, does it also govern the flicker of thought? So what is the physics of the mind? It's the search for a bridge between energy and meaning, between patterns and perception. It's the idea that thought is not some magical exception to the universe, but another ripple inside it, structured, costly, and maybe governed by laws we haven't fully discovered. The mind might not be made of light or matter, but it moves like them, and it obeys something deeper than biology, a rhythm written into the code of the cosmos. Where does consciousness come from? Every thought you've ever had, every sound, color, memory, feeling, all of it happens inside your head. But why does it feel like anything at all? Your brain is a physical system, cells firing, chemicals flowing, circuits activating. But somehow, those signals don't just process information. They create an inner world, a subjective point of view, a place where the universe is felt. This is consciousness, and no one fully knows how it works. We can explain the mechanics. The brain receives input from the senses, processes it in networks of neurons, and produces output, movement, speech, memory. But that's the easy part. The hard part is this. Why should any of it come with an experience? Why doesn't your brain do all that in the dark without awareness? This is what philosopher David Chalmers called the hard problem of consciousness. Not how the brain functions, but why its functions are accompanied by feeling. Why seeing the color red isn't just data processing, but something you experience. One major theory is integrated information theory, IIT. It suggests consciousness arises from the degree to which information is interconnected. The more unified and irreducible the system, the richer the conscious experience. Think of it like a symphony. If each instrument played in isolation, there'd be no music. But when they're synchronized, something emerges that wasn't there before. Another is global workspace theory, GWT. It proposes that consciousness is what happens when information is made globally available across the brain, broadcast like a spotlight to multiple systems. What you become aware of is simply what wins that internal competition for attention. Others go deeper. Some argue that consciousness might be a fundamental property of the universe, like space, time, or mass. According to panpsychism, even particles might carry a trace of awareness. Not thoughts, not feelings, just a primitive glimmer of experience. And from that, minds may emerge through complex arrangements of matter. And then there are those who suggest it's all illusion, that consciousness doesn't exist the way we think it does. It only feels real because the brain creates a convincing story. But illusion or not, it's the most undeniable part of existence. You might doubt what you know, you might question what you remember, but you can't deny the fact that you're experiencing something right now. So, what gives rise to consciousness? Maybe it's integration, maybe it's information, maybe it's a hidden law of nature we haven't discovered yet. But whatever it is, it gives life depth. It turns matter into meaning. How many levels of consciousness are there? We often talk about consciousness like it's a switch, on or off, awake or asleep. But awareness doesn't work in binary. It moves in gradients, pulses in rhythms, and stretches across layers. Consciousness isn't a light, it's a dimmer. Neuroscience suggests that consciousness has levels, from deep dreamless sleep to full alertness, from fragmented sensations to unified awareness. But it also has types, distinct expressions of experience that serve different purposes. Let's start with levels. At the base is unconsciousness, not just sleep, but deep anesthesia or coma, states where brain activity becomes disconnected, scattered, or silent. The body may still function, but there's no coherent experience tying it all together. Above that is minimal consciousness, brief flickers of awareness like moments in light sleep or in certain brain injuries. The mind drifts, perception is fragmentary, memory may never form. Then comes ordinary waking consciousness, our default mode. Sights, sounds, thoughts, memories, everything stitched into a single stream. It feels seamless, but even this state is a balancing act between attention and distraction, control and autopilot. Higher still is the flow state. Complete immersion. Time distorts. Self-awareness fades. Athletes, artists, and programmers describe this as peak performance, where action and awareness merge. It's not hyper-awareness, it's focused awareness. Then there are altered states, induced through meditation, psychedelics, trance, or sensory deprivation. These states can bring radical shifts in perception, identity, and time. Some feel expansive, others disorienting, but all reveal that consciousness isn't fixed, it's elastic. And above all, there's meta-consciousness, the awareness of awareness itself. When you reflect on your thoughts, question your attention, or catch yourself drifting, you're stepping outside the stream and watching the water move. But levels are only half the story. There are also types of consciousness, each serving different roles. Sensory consciousness is tied to the external world. Sight, sound, touch. It's the window into reality. Emotional consciousness gives feeling to experience, coloring thoughts with urgency, memory with meaning. Self-consciousness is the mind's ability to recognize itself as a subject, to say not just pain exists, but I am in pain. Social consciousness models the minds of others, what they know, want, feel. Without it, there's no empathy, no culture. Temporal consciousness gives you time, the ability to recall a past, imagine a future, and understand the present as a moving line. So how many levels are there? Technically, dozens. Some researchers map 5, others suggest hundreds. But maybe the point isn't the number. Maybe what matters is the range, from silence to symphony, from instinct to introspection. The more layers we recognize, the more we understand that consciousness isn't a state we enter. It's a field we move through, one that bends, folds, stretches, and sometimes even vanishes.